the last example, and we're going to look at, again, whether we are solving for compound interest or present value. And so, again, they both look at the exact same equation, and sometimes you might need to solve for a different variable in those equations. So let's take a look at the last example. So it says, Aunt Jemima has given her nephew Lego $12,000 to pay for his university education, and Lego expects to start university 4 years from now, and when he estimates the cost will total $17,000. At what interest rate, compounded quarterly, does he need to invest the money? So if we take a look at the information that we have, the $12,000 is how much money he needs to invest right now. So that's the principal amount. The $17,000 represents how much money he needs to have at the end of the 4 years. So that's the accumulated amount. We're told how long he's investing for, which is important to help us figure out the number of compounding periods. And we're also told that the interest is compounded quarterly, so that'll help us figure out the number of compounding periods and the interest rate per compounding period. And what we're looking for is what the interest rate is that he needs to invest the money in. So let's start by looking at the formula for compound interest. And let's list the information that we know. We know that A is equal to 17,000. We know P is equal to 12,000. And we know the interest rate per compounding period is whatever the interest rate is that we actually need to solve for. And we've looked at a question like this earlier as well. So this one's just a little bit different. So the interest rate per compounding period is whatever the interest rate is per year divided by how often it's compounded in a year, which is 4 times, since it's compounded quarterly. And then the number of compounding periods is 4 times a year, since it's compounded quarterly, times the number of years, which is 16. Okay, so let's plug in the information that we know. Like we did earlier, we're going to leave I the way it is, and we're going to plug it in later. So there's Lego asking you to let go of his ego. And so if I plug in the information I know, I have 17,000 equals 12,000 times 1 plus I to the exponent 16. And just like we did earlier, we're going to divide both sides by 12,000. And on the left-hand side, I get 1.41666666. So it keeps repeating. I'll just put a bar on top of the on top of the 6. And on the right-hand side, I get 1 plus I to the exponent 16. Now, because I'm trying to isolate I, but there's an exponent applied to it, I need to do the opposite of an exponent, which is a root. And so what I'm going to look at is the 16th root of both sides. And so what that'll do is it'll eliminate the 16th root and the exponent of 16. So on the right-hand side, I'm left with 1 plus I. And on the left-hand side, I can find the 16th root of this number. And I'm going to try to put in as many 6's as I can on my calculator just to try to get an accurate solution. And I'm going to look for the 16th root. And I get about 1.022 approximately. Now if I subtract 1 from both sides, I end up getting I is approximately 0.022. So that's the value of I. However, I'm trying to figure out how much interest he's earning on an annual basis, or what the investment interest rate should be. And so I'm actually trying to solve for R. So I'm going to take this and plug it into that equation. And so if I replace R with R over 4, I get R over 4 is equal to 0.022. And if I solve for R, I get 0.088 is equal to R. So as a percentage, this is 8.8%. Okay, so I just multiply by 100% to get 8.8%. So therefore, the interest rate he needs is 8.8% per annum, compounded quarterly. Okay, and that's pretty much it. Here's your assigned work. From your textbook, you have a couple pages, a few questions. questions in each page, and that's pretty much it.